that 2 times 1/2 is the same as saying, oh, move that up a little bit, 2 over 1 times 1/2, which is just 2 over 2, which is just 1. Okay, so this just becomes 1. So you have x plus 1 equals 7. Subtract 1 from both sides. You have x equals 6. Okay, so we know our solution is 6 and 1/2. Six comma 1/2. Oops, there we go. And again, if you want to double check, you can just plug it into both of those equations and it works out. All right, any questions on this one? Okay. Okay, now all 3 of those had one solution. You're going to come across some instances where you have either no solutions or you'll have an infinite number of solutions. And both of those are where you'll have your inconsistent and dependent systems. Okay, so let's say if we decided to solve, nope, make sure it's not yet. If you want to solve the system, let's say x minus 2y equals 6, and x equals 6 plus 2y. Uh-oh, didn't need that. Okay. Now, if you look at it, you can kind of tell it's really just the same equation, written differently. But if we did decide to just go ahead and plug that in, let's say x equals 6 plus 2y, so we can substitute. Okay, so x minus 2y equals 6 will just become, we know 6 plus 2y is equal to x, so you have 6 plus 2y minus 2y equals 6. Okay, so we don't, these are positive outside the parentheses, so that's just 6 plus 2y minus 2y equals 6. Plus 2y and minus 2y cancel each other out because they equal 0. So that disappears. So you're really just left with 6 equals 6, which is a true statement. Now the thing is, when you're left with a true statement and all the variables have disappeared, then that means that whatever's true for one will be true for both because they're just the same thing. They're the same exact equation. So when all variables have disappeared, and you are left with a true, that's going to be really important, statement, then there are infinite solutions. And when there are infinite solutions, that means it's a dependent system. Okay. So remember, you may end up with 6 equals 6, or 10 equals 10, or 12 equals 12. Anytime it's just a true statement where they're both equal and all the variables have disappeared, that means it's going to be infinite. Okay, so let's try this one for example. Let's say if we wanted to solve the system. Say 6x plus 12y equals 5, and negative 4x minus 8y equals 0. Okay. Now we don't have any isolated variable. We don't have an x by itself or a y by itself. So we have to make one. Okay. So let's say if we have negative 4x minus 8y equals 0, if we add 8y to both sides, plus 8y plus 8y, these two cancel each other out because they equal 0. So that leaves us with negative 4x equals 8y. Okay. Now if we want to solve for y, we just divide both by 8. If we want to solve for x, we divide both sides by negative 4. We can do either one. So since dividing by negative 4 will give us a whole integer and not a fraction, we divide both sides by negative 4. Okay, negative 4 divided by negative 4 is 1. So that gives us x equals 8 divided by negative 4 is negative 2. And don't forget your y that's right there. Okay, so once again we were able to solve for a variable so we can substitute. Okay, so now we substitute. All right, so we just plug that into the first equation. So that means our 6x plus 12y equals 5. Now that we know that x is equal to negative 2y, it will become 6 times negative 2y plus 12y equals 5. Okay, so 6 times negative 2 is negative 12. So negative 12y plus 12y equals 5. You kind of see now that negative 12 and positive 12 equals 0. So we end up with, sorry about that, 0 equals 5. Which we know is not true, so that's a false statement. Okay, so the one before, all the variables disappeared, left us with a true statement. With this one, all the variables disappeared, left us with a false statement. So when all variables disappear, and you are left with a false statement, then there are no solutions. Which means it's an inconsistent system. Okay. Any questions on that one? All right. Oh, one quick other thing. The problem before, where you had the true solution, it is actually a consistent system. Because remember, if there are an infinite number of infinite number of solutions, a system is consistent if there's at least one. So the fact that there are an infinite number means that there is at least one. So if there's at least one, this is both dependent and consistent. Okay, make sure I didn't forget that part. Okay, any questions on this one? Oh, it kind of rolled down a little bit. Any questions? All right. Okay, so that was our substitution. Now we're going to use either elimination. Some books call it elimination. Some people call it adding. It's pretty much the same thing. So we're going to solving systems. Of linear equations. Using the elimination method. And sometimes it's called the addition method. All right, so this one has a few extra steps in compared to the other method. Okay, so we'll just write down those steps. Steps for the elimination method. Okay, so step 1, you want to rewrite it in standard form. Rewrite both equations in standard form. Okay, and that just means ax plus by equals c. All the variables are on one side, where a, b, and c just represent numbers. I just put them in place to mean any number at all. Okay, so as long as all your variables are on one side, it's in standard form. Okay, so the second, only if it's necessary, you want to multiply either every term in one equation or every term in both equations, so that when you add the two together, one of the variables cancel out. And we'll go through each step. Multiply one or both by a non-zero number. So the coefficients, remember the coefficient is just the number in front of the variable. Of the chosen variable has opposite signs. Okay, so you want one to be positive, one to be negative. Okay, third step, you want to add the equations. Okay, fourth step, once you add the equations, it's going to get rid of one of them. So you want to solve for that variable. So you want to find the, sorry about that. I remember to slide that up. Find the value of the variable that is remaining from step 3. Okay. Step number 5, then you're going to plug that variable into either equation and solve for the other one. So find the value of the second equation, means second variable, by substituting the variable from step 4. Okay. Then after that, you can check your answer if you like by plugging them into your equation. That's optional. You can do it if you want to, but it's kind of suggested to make sure you didn't mess up anywhere. Optional, but recommended. Okay. Oh, sorry about that. All right, so let's say if we start with the problem. With the example, solve the system. Okay, and we'll start off with one where you don't have to really do much to it. X plus y equals 7. X minus y equals 5. You could solve this one by using substitution, but we're going to use the other method, the elimination method. All right, so your first step is to make sure that they're in standard form, all the variables on one side. So the first step, already in standard form. Okay, so we don't have to worry about moving any variables over. Okay, so your second step is you don't have to multiply these by anything because you already have a positive y and a negative y. So if you add these two together, the y's would disappear, which is really all you want. You want one of the variables to disappear. Okay, so you don't have to multiply by anything. Since the y's will disappear when added. Okay. Now your third step, you're just going to add the two equations together. And if you just line them up right on one on top of the other, x plus y equals 7, x minus y equals 5. Just go ahead and add them together. You have your x plus x. Oh, move that up a little. X plus x is 2x. Negative y plus y is 0. So just what we wanted, one of the variables disappeared, which is exactly what we wanted. Equals 7 plus 5 equals 12. Okay, so now we just have to solve for x, which is happening by dividing by 2. So we have 2x equals 12. Divide both sides by 2. Anything divided by itself is just going to equal 1. Okay, so we have x equals 12 divided by 2, which is 6. Okay, so we're done with step 3. We solved for one of the variables. So now step 4, we're going to use that variable and plug it into either one of those equations to solve for y. Okay, so that gives us, you can pick either one, either the x plus y or the x minus y. Both will work. So let's say x plus y equals 7, which means that 6 plus y equals 7. subtract 6 from both sides, we know that y is equal to 1. Okay, so we have our x and we have our y. Oh, did I skip a step? 2, 3. Oh, why did I just repeat the steps? I just realized that. Exactly, I just wrote the same step over again, so we can eliminate one of them. So it should just be 5 steps. Okay, so now we have our solution, which is, remember, x comma y, so it's 6 comma 1. And if we wanted to check it, we could just plug it right in there. 6 plus 1 is 7, 6 minus 1 is 5, so we have our solution. Okay. And for the steps, I just scribbled out number 5 and made that one 5. I don't know why I did that twice. All right, so any questions on that one? All right, so what we'll do now is get one that's a little bit tricky. Not super tricky, but just a little bit. Okay, so if we want to solve the system, negative 2x plus y equals 2, and negative x plus 3y equals negative 4. And again, if we want to solve it by substitution, we could. We can just subtract 3y, multiply both sides by negative 1. We have our x. But we're going to go ahead and use the elimination method. Okay. So now, first thing you want to do is make sure it's in standard form. Okay, which means every variable has to be on the left side. Okay, so we have all of our variables here, so it's already in standard form, so you don't have to worry about that. Okay, now the second step is you want to be able to add them together so one of the variables disappear. If you add the x's together, bring that down, it wouldn't disappear. If you add the y's together, it wouldn't disappear. So you have to figure out some way to make it to where either the x values or the y values either have the same coefficient but different signs. Okay, so that means you would just multiply either one of them with a variable, with a number that will cause it to disappear. So that means if we multiply this second equation by negative 2, that would turn this x into a positive 2, which means if we added them together, the x would disappear. Or if you wanted to, you can multiply this top one by negative 3. That would cause that to be a negative 3y, which means the y would disappear. So there's no one number you have to multiply it by. You literally have, in this case, 4 different options. So if you want to get rid of the y, you can multiply it by 3. If you wanted to, you can do it any number of ways. I usually pick the one that will look the least irritating. So to me, that's the x. It just looks like it'll be less trouble. Okay, so we'll multiply, just to clear it up, we'll call that equation 1, and this equation 2. Okay, just for clarity. Okay, so we're going to multiply equation 2 by negative 2, so the x value, or x variable, will disappear when we add it. Okay, so let's go ahead and do that. So that means our negative x plus 3y equals negative 4 we have to multiply every term by -2. So multiply every term by -2. Okay, that's the only way the equation is still going to have the same value. So you have -2 times -x plus -2 times 3y equals -2 times -4. Okay, so we just got each one of those terms and multiplied by -2. Okay, so -2 times -x, -2 times negative, negative and negative is positive. So we have a positive 2x. -2 times +3 is -6, so we have -6y.